All right, guys. So, just to review from yesterday. All right. So, yesterday we were talking about the different ways to solve rational equations. The main way that we talked about yesterday was the proportional method. What's the only circumstance that you can use the proportion method? So, cross multiplying, in other words. Opposite of that. Right. So you can only use the cross multiplying method when there's only one fraction on each side to equal sign and nothing else added or subtracted to it. So it literally looks like something like this. So like 1/2 is equal to 1/x. That's the only time you can use the cross multiplying method, if it looks something like that. So one fraction bar on each side, nothing else added or subtracted outside those fraction bars. Now, the other method that we learned was what? So for any other rational equation, what's the other method that we have to use? Proportional is the one we just talked about. That was cross multiplying. What's the other one? Starts with an L. Least common denominator method. So LCD method. All right. That's when you find the least common denominator, multiply it to all the numerators so you can divide all the denominators out and leave you with nicer equations to solve. So that's what we're going to start with today. We're going to continue doing a couple more least common denominators, because then what we're going to do after that is do some word problems. All right. So let's look at exercise 4, example A on page 10 of your packet. So first things first, we clearly have more than one fraction bar on each side of the equal sign. There's 2 here and 2 here. All right. So we definitely have to use the LCD method. Now, does anyone want to take a guess what the LCD is going to be? So let's kind of figure this out. So first off, let's look at the numbers. What are the 3 coefficients that I have for all the denominators? So what are the only numbers that I have in this? 10, 5, and 1. Good. All right. So between 10, 5, and 1, can 5 go into 10? Can 1 go into 10? Can 10 go into 5? Evenly. Without creating a fraction? No. So, since 5 can go into 10 and 1 can go into 10, we're going to assume that the least common multiple, the numerical part, is 10. These are questions you need to ask yourself. If it didn't work out that way, just multiply the numbers together. So you could have used 50 and it would have worked too. 10 times 5. You could have also used, 10 or 50. You could have also used 20. You could have used 30. Literally any multiple of 10 and 5. All right. But when in doubt, multiply them together. It will at least give you a common denominator. Now, look at your variables. What are the only 2 types of variables that you have? X and x squared. All right. So if I look at x and x squared, which one do you think I'm going to use for the least common denominator? X squared. Why x squared and not x? Could I make x squared if I was given x originally? Like, could I multiply something to x to give me x squared? Can I multiply something to x squared to give me x squared? Yes. So that's what you're asking yourselves. Out of all the denominators, you're like, okay, can I multiply something to 10 to give me 10? Can I multiply something to 5 to give me 10? Can I multiply something to 1 to give me 10? If the answer to all those questions are yes, that's your numerical denominator. Same thing with your variables. Can I multiply something to x to give me x squared? Can I multiply something to x squared to give me x squared? So our least common denominator in this case is 10x squared. So now what we're going to do is we're going to multiply the entirety of this equation by 10x squared over 1. So in other words, our denominators are going to remain the exact same. So if you want to start by writing out your denominators again, that's fine. And then we're just going to multiply 10x squared to all of our numerators. So there's 3 1s, so 10x squared times 1 is 10x squared. So this will be 10x squared, 10x squared, 10x squared for the first 3. What's 10x squared times 2? 20x squared. Good. So that's my last one. Now we're in simplifying mode. What does 10x squared over 10 simplify down to? Just x squared. The 10s divide out. We're left with x squared. What does 10x squared over x divide down to? 10x. So one of this x goes away and the square goes away. We're left with a singular x connected to the 10. So minus 10 is equal to, what about 10x squared divided by 5x? 2x. So the x goes away down here. This becomes a singular x. The 5 goes away. This becomes a 2. So this will be 2x. And then 20x squared divided by x squared. It's just negative 20. The x squareds cancel out. So remember, the goal of the LCD method is to get it so that all your denominators divide out. If they don't, you did not have a common denominator. All right? Yes. Yes, it should. I just forgot to write it. All right. So the goal is to have a common denominator so that your denominators of your original fractions divide out. So we're trying to change the numerators so that our denominators go away. That's the whole point of finding the least common denominator. Now I can solve. So this is clearly what type of equation? Linear or quadratic? There's one variable that gives away whether it's linear or quadratic. What do you think it is? It's quadratic. Why? That x squared. Since we have an x squared, if we have anything squared in there, it's quadratic. Linear only has x's. There's no variables. All right. So we got to get one side equal to 0. So I'm going to subtract the 2x to both sides. So I'm going to subtract it to the 10x. Goes away. X squared minus 12x is equal to negative 20. What's the last thing I need to do to get one side equal to 0? Add 20. Now, is there anything for 20 to be added to on the left side? Is there any common or like term for it to be added to on the left side? No. So we're just going to throw it on at the end. So after the 12x. So that goes away. You get x squared minus 12x plus 20 is equal to 0. So guys, if you ever end up with, when you're adding and subtracting stuff over and there isn't a like term on the other side, that's completely okay. Just make sure you add it on or subtract it on at the end. Or like in its place where it goes in standard form. All right. Now, which method did I tell you yesterday that you should check to see if you can do first? So there's 2 main methods for solving quadratics. What's one of them? Factoring. What's the other? Quadratic formula. So remember, quadratic formula works for any quadratic, but the easier one is what? Factoring. So you always want to check to see if that quadratic factors first. If it does, solve by factoring. If it doesn't, you're going to have to use quadratic formula. All right. So we're going to check factoring first. So I'm going to do my big X. What goes on top of the big X? A times C, which is 20, because that's 1 times 20. What goes on the bottom? our b value, or negative 12. So I need two numbers that multiply to give me positive 20, add to give me negative 12. So if we're multiplying to getting a positive number but adding to a negative number, that means both my signs are negative. So what do you think those two numbers are, Landon? Negative 10, negative 2. Good. And since we have an a value of 1, we can just use the shortcut method. So we always start with x, and then we add or subtract our factors based off of their signs. So minus 10 minus 2 equals 0. Just like that, it's factored. What's my last step for solving? So we got factor, but it's not solved yet. Landon. How? I got to do something before you do that, Tomas. Right. Set each factor equal to 0 individually first. So you want to create two mini equations. So we have x minus 10 equal to 0, x minus 2 equal to 0. So we just split them apart. And then we solve them individually. So add 10 to both sides for the first one. X is equal to 10. Add 2 to both sides for the second one. X is equal to 2. Now, before I signify that those are my answers, what did I tell you always need to check for? Starts with an E. Extraneous solutions. What does it mean if it's an extraneous solution for a rational? What's the one thing that you cannot have in a fraction? 0 where? In the denominator. So if you plug back any one of these x's in for any of the x's in the original equation, then if the denominator becomes 0, it's not a solution because anything divided by 0 is undefined. All right. Luckily for us, stupid thing. Luckily for us, 10 and 2 will work out with these and not become 0. So both of these are stop moving. So both of these are solutions. So your solutions to this one is x is equal to the set of 2 and 10. They both work. But just take that quick moment, and if you have x's in those denominators, take a quick moment, put them back into all the denominators that contain an x. Make sure you don't get 0 anywhere. All right, it should take you like 2 or 3 seconds. All right, any questions on letter A? All right. Do you guys want to do letter B, or can I move on to a little bit of a harder one? Letter B is about the same as letter A. How are you guys feeling about this? Okay? Pretty okay? Do I need to do letter B? Should I take it out of a vote? So it's up to you guys. What do you guys think? Yes, no, maybe, yes? Do it? Okay, move on. Okay. So I'll move on. All right. So this last one is a little bit more complicated, but not really. It's just instead of having monomial factors, you now have the binomial factors, kind of like we did when we were adding and subtracting, but it's a little bit easier because we don't have to worry about all the combining and all that loveliness. So because fractional equations often involve denominators containing variables, it's important that we check to see if any solutions of the equation make it undefined, and these are extraneous roots. So again, extraneous roots means if you plug in for x, whatever answer you get for x, it makes the denominator 0. If you have a denominator of 0, it's extraneous. Now, My question to you guys is, can you have a numerator of 0? So if I had 0 in the numerator, is that a true, like it still gives you an answer? Yes, because what's 0 divided by anything? 0. 0 is still a number. It does not mean undefined. 0 and undefined are completely different things. Because technically 0 is a defined number. Undefined means there's no number in the span of the number world, whether it be imaginary, real, complex, whatever, that would fit and make it work. All right. So we're going to solve these next two examples and then reject any extraneous roots. So we're going to take the time to check it. So first things first, before we even figure out what our LCD is, because we're obviously going to have to do it because we have two fraction bars on one side of the equal sign. I'm going to want to factor the trinomial denominator real quick because then it'll make it really easy to see what my LCD is. All right. So how would I factor that denominator? So I have 15 on top, 8 on bottom. What's two factors of 15 that add to 8? 5 and 3. So if I rewrite this, I have x plus 1 over x plus 5 plus 18 over x plus 5 times x plus 3 equals 9 over x plus 3. And just like that, it's pretty easy to see what your LCD is. Because what do you think I can multiply? What denominator do you think I could have where I could multiply something to each fraction to get it? Not 15. So look at these denominators. Remember what I said about adding and subtracting, very similar to that. It's a game of what are they missing, what do they have in common? What do at least two of the fractions have in common? What's one thing that two of the fractions have in common in the denominator? Not just 5 and 3. Not just x. We're talking about married couples here. X plus 3 and x plus 5. So, since the first two fractions share an x plus 5, that's part of it. And since the second two fractions share x plus 3, that's part of it. Because remember, if this is our denominator, we can just multiply x plus 3 to this fraction to get the denominator. We can multiply x plus 5 to this fraction to get that common denominator. All right, so this is our LCD, or least common denominator. That's what we're shooting for. Because if we multiply that to our entire numerator, all of these binomials will cross out. All right, that's the goal. We want those binomials on the bottom to cross out, like when we're simplifying. All right, so now I'm going to go ahead and multiply everything by my LCD. So x plus 3 times x plus 5 all over 1. Now, it looks like it'll be a complicated multiplying. It's not. We're just going to write it in terms of multiplication and not do any foiling or boxing or distributing. All right, so we're just going to write it in terms of the multiplication itself. Like, like the pre-problem, like what it looks like before we actually do the multiplying. So I'm going to rewrite all of my denominators. So x plus 5 plus x plus 5 over x plus 3 is equal to x plus 3. And then I'm going to distribute all of these. So if I rewrite the first fraction with all three of those factors, what would it be? How would I write it? And you don't have to box it or anything yet. What would it look like? So you start with x plus 3 times what? X plus 5 times x plus 1. That's all you got to do. So when I say multiply, like in terms of multiplication, that's literally what I mean. Just write them all next to each other and don't put anything else between them. The reason we don't want to FOIL yet is because we want to be able to cross stuff out. So don't do any distributing. Don't do any boxing. Don't do any foiling until you've crossed stuff out already. What about the next one? What would it be? Right. So I'm going to put 18 up front because that's just kind of the nice placement. We have a number and do x plus 3 times x plus 5. And then the last one will be 9 times x plus 3 times x plus 5. Now, before we go any further, we're going to look at each fraction individually and cross out stuff that we need to cross out. All right. So out of the first fraction, what can I cross out? What do I have in common with the numerator and denominator of the first fraction? X plus 5. So those go bye-bye. And what am I left with of the first fraction? X plus 3 times x plus 1. What about the second fraction? What's there? X plus 3 goes bye-bye. X plus 5 goes bye-bye. What am I left with? So what am I left with? 18. So this would be plus 18. Is equal to what goes bye-bye in the last fraction? X plus 3. And I'm left with 9 times x plus 5. So that's why you don't do any multiplying through yet, because you want to be able to cross out all that stuff. Because if you multiply through, you just end up having to factor it again to be able to cross out stuff. Because remember, you want it in those open relationships instead of those exclusive relationships. As soon as you distribute and FOIL, you make the exclusive relationship. And then you just have to undo what you already did. All right? Does everyone understand up till this point? All right, now we're in solving land. So first things first, we just need to simplify the equation as much as we can by distributing, FOILing, and combining like terms. All right. So I'm going to do a quick FOIL for the first ones. So this will be first is x squared, outer is 1x, inner is 3x, add them together, that's 4x. And then last is plus 3. Bring down the plus 18 is equal to distribute the 9 to the x plus 5, 9x plus 45. What's the last thing I need to do to clean it up, at least on the left side? Let's look at the left side of the equal sign. What's the last thing I need to do to clean it up? Combine the like terms, which is just the 3 and the 18. So this would be x squared plus 4x plus 21 is equal to 9x plus 45. So this is clearly what type of function or equation, sorry. Is it quadratic or linear? It's quadratic. So we either want to solve by factoring or quadratic formula. So let's hope it's factorable, all right? But with either version, we have to always get one side equal to what? 0. So I'm going to start moving things. I always move stuff from the side where the x squared is not, because I want that x squared to remain positive. It makes your life so much easier if it is. So I'm going to start by subtracting my 9x. What do I subtract the 9x to on the left side? The 4x, because that's the like term. So that goes away. I get x squared minus 5x plus 21 is equal to 45. Then I subtract the 45 over because I still need to get one side equal to 0. And I'm going to subtract it to the 21 because that's the like term. So that would then be x squared minus 5x minus 24. Correct me if I'm wrong. equals 0. Now, I can tell you right now, this one will factor. All right, so we're just going to go ahead and do factoring method. Or do you want me to show you quadratic formula just for shits?
I mean, who said that? Anyway, you should show us that.
We'll just have to cut that out of the video there. All right, so okay, so does anyone want me to show you guys quadratic formula just so you kind of know what it looks like? Like, this one is factorable, but do you guys want me to show you just in case, like, you have to do a quadratic formula? You're gonna have to see it. You're gonna see it. Trust me.
Okay, when would we need it?
The quadratic formula on the EOC.
When are we gonna learn it?
Learn quadratic formula. It's all through. You should have already learned it back in math too.
Yeah.
So it's more of a, I expect you to already know it. That's why I'm asking if I need to go over it.
I don't think they want to go through. Probably.
So I'm gonna do the quadratic formula just so you guys can see it. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, the numbers, only numbers go in the quadratic formula, no variables. So no letters will be seen in the quadratic formula. Yes. Yeah. Now, I'm going to label this as ABC. So it always goes, the x squared is connected to the a, the x is connected to the b, and the c is the constant. So just to write it over here, a is equal to 1, b is equal to negative 5, c is equal to negative 24. Now, I'm just going to put everything in the formula, but I'm not going to evaluate anything. So whoa, that was weird. So x is equal to negative b, which is negative 5, plus or minus the square root of negative 5 all squared minus 4 times a, which is 1, times c, which is negative 24, all over 2 times a, which is 1. So all I did was replace the letters a, b, and c with the values, with their respective values. I have not done any evaluating. I just put it in the formula. Now I'm going to evaluate. So whenever you do quadratic formula, I suggest you just do one step at a time. All right? Because if you try to put that all in your calculator, first off, if it's an imaginary number, your calculator will say error. Second off, with quadratic formula, most often than not, you have to simplify the radicals, or there's just some more simplifying to it. It's just a pain in the butt. So you just got to simplify it one step at a time. So I'm going to start with just the middle parts, just all the multiplication. So the squares and the multiplication I'm going to take care of. So a negative times a negative is a positive, so it's going to be positive 5 plus or minus the square root. Negative 5 squared is positive 25. Negative 4 times 1 is negative 4 times negative 24. Let's see, 4 is 16. 20 times 4 is 80. So that would be 96. So minus 96, plus 96, because negative times a negative, all over 2 times 1, which is 2. So I've just done all the multiplication. Now I'm going to take care of what's under the radical. So I have 5 plus or minus the square root. 25 plus 96 is 121. No. Is that right? Yes. Okay. 121 all over 2. 121 is, in fact, a perfect square. So the square root of 121 is 11. So I have 5 plus or minus 11 over 2. Now, since I have all numbers left over and no radicals, your last step is to separate the plus and minus and evaluate. So this would be 5 plus 11 over 2, and then 5 minus 11 over 2. So 5 plus 11 is 16 over 2. 5 minus 11 is negative 6 over 2. I don't know why I wrote 3. And then this one simplifies down to 8. This one simplifies down to negative 3. And those are your two answers. And you would have gotten that in far less steps if you just factored this as x minus 8 times x plus 3 is equal to 0. X is still equal to 8. X is still equal to negative 3. So that's why factoring is easier, all right? But sometimes if it's not factorable, you do need to do quadratic formula. It's going to be rare, but it's just good to know how to do it because you may come across that where you have to. Now, let's check for extraneous solutions before we're done. Is there any x value, so negative 3 or 8, that if I plugged it in for any of these denominators in for x, that would make a 0? So let's check 8. So what's 8 plus 5? 13. So there'd be 13 here. What's 8 plus 3? 11. So you do 13 times 11. That still gives you a non-zero number. And then 11 here. So 8 works. What about negative 3? So what's negative 3 plus 5? 2. So that's 2. What's negative 3 plus 3? 0. What's 0 times anything? 0. And then right here, still gets 0. So since x plus 3 gives us 0, it's an extraneous solution, so it's not one of our solutions. So this is an extraneous solution. So our true answer is x is equal to 8. That's the only viable solution. So that's why you got to take the extra minute, check for the extraneous. And you don't have to plug it in for every x. You just need to plug it in for the x's and the denominators. All right, and make sure you're plugging it into the original unsimplified equation. All right, any questions on that? All right, so let's do this. Let's go ahead and take your 5-minute break, and then we'll come back and do the word problems, just to kind of let it, simmer for a minute. So I'm going to go ahead and start the timer. Make sure you're back by the time the timer goes off.
I have the world's tiniest and biggest computer. I don't know where my computer is. I looked.
You lost the packet again. Didn't I just give you one last week?
Yeah. Am I going to have a binder now? Yes. I thought you were going to try. No. It's all. You clean it up, so you can. Oh, you need to calm down. Let me try to put on your tongue. Don't let it was oh, pocket full of money. That's really music. I am thirsty. I think I figured out what the fact that it doesn't have air under it. It's not that. It's the all the water companies know that it's all crowding your space with other holes. It's their air up here and not water. So it's like, if it was completely full, it wouldn't make that sound. Oh no, that's the same sound I heard. Oh my god, you can that show. What is it doing this? This flavor is so sucking. His work. Why give it to me? Because that's your problem. It's a ghost dog. Look at the ghost dog. It looks like you're special. That's why you're here. That's we? That's just you. We? There ain't no we in this. That is all you. I remember the video still running. We is just you, man. We is just you. You're the one saying controversial stuff, and the video is still rolling. That dog looks adorable. I'm pretty sure it's a husky as well. We feel it's a little good. You think it's something more than that? Yeah, but then where you go. I'm trying to go down the hallway. Where else am I gonna go? The history hallway? One downstairs. Why would I go to downstairs for the water? The one downstairs? Those all downstairs for the water. That's right. Look, there's a lot downstairs. I went from English all the way to cafeteria water fountain. And it's still on. It's the only one in the building on green. Every single one. I tried to get the one, I tried to get water at the one, wall. It wouldn't put out water. It is that bad. It's not working. Stop. I think they can that one off though. That's the one I use it for me. Oh yeah. So I can't get out of it. No paper. So guys, go ahead and have page 13 open. That's when we're going to start after the vote. All right, y'all. So, let's go ahead and pick back up where we left off. So now we're gonna start with the word problems. All right. So we're on page 13 of your packet. Now, in my opinion, the word problems, like the equations actually solve the word problems, are actually easier than some of the ones that you'll actually be, you know, given. Like if I just gave you an equation and told you to solve it. The hard part about the word problems is setting them up. But in reality, it's just logic. You just got to think about it logically. All right. So let's talk about this. So a lot of rational equations that you're going to be dealing with has to deal with distance, rate, and time. So the distance formula. You probably learned this back in physical science or one of your science classes at some point. You may have also learned it in one of your earlier math classes. But just to recap, distance is equal to rate times time. So how fast you're going and how long it takes you to go. That's how
That's how you can calculate how far you went. So in other words, think about this for a second. If I'm driving my car at 55 miles per hour, I have the cruise control on, it's not going any faster, and I drive for an hour, how many miles did I go? 55. That's why it's a rate. 55 miles per hour, that means in 1 hour I went 55 miles. All right. If it was a constant rate of motion. All right, which that never happens, but these are all theoretical. Now, D equals R times T. However, the main formulas that you're going to use is if you find the rate, which is D over T, or if you find the time, which is D over R. So just knowing those three are pretty important. And if remembering them is kind of hard, you can always do the triangle method, which is if you have distance here and then rate and time. Rate times time gives you distance. And then distance over rate gives you time. Distance over time gives you rate. That's how you can read that triangle. So the triangle just kind of shows you if you did D over T, that gives you what's left over, which is R. If you did D over R, that gives you what's left over, which is T. And if you did R times T, because they're right next to each other, that gives you D, which is distance. All right. Now, let's actually try setting up some of these word problems. So in other words, we got to do a little bit of, thinking. So one of the types of problems that you'll see is the upstream, downstream. All right. So, we're in Morehead City. Boating's pretty common. All right. You kind of have to think about it logically. So if you've ever been out boating before, especially if you've ever driven a boat before or, paddled a boat or whatever, you may know what some of this stuff means. So, Reuben went canoeing on the Neuse River last Saturday. He traveled 20 miles downstream and then turned around and traveled the same 20 miles upstream. The trip took him a total of 7 hours. If his canoe travels at 8 miles per hour in still water, what is the speed of the current of the river? So, where all my boaters at? Anyone ever been on a boat, driven a boat? All right. So, what does it mean if you're going downstream? Are you going with or against the current? You're going with the current. So, does that typically make you go faster or slower? Faster. So, right here, downstream, it means you're going faster because you're going with the current. Upstream is the opposite. You're going against the current, which makes you go slower. So, how I typically tell you guys to set this up is we know the distance. It's 20 miles. So it's the same distance. So both of these are my D. We know how long it took. And we also know that they're going 8 miles per hour in still water. What does it mean if it's still water? I know that's dangerous for boating, but what does it mean? There's no current. So still water means no current. Yeah, that's not, ideal. Typically, I don't think you'll ever be in a body of water that doesn't have a current unless you're just in some weird pond. But yeah. Now, how we're going to figure this out is we're going to write different expressions in terms of rate and time. So we want to find the speed of the current. And to do that, we want to find the actual speed that we were going with the current and against the current. All right, what that actual miles per hour was. Because if we go 8 miles per hour in still water, that does not account for the current. All right, whether we're against it or with it. So this table is kind of a good setup for how you may want to set up your problem. I highly recommend at least jotting it down every time you do this. So your distance is exactly the same. Now, your rate, you're writing in terms of it's your still water, how fast you're going in still water, plus or minus whatever the speed of the current is. So why am I adding the current speed if I'm going downstream? Why do you think? Because you're going faster. So on the opposite end, if I'm subtracting the current, that means I'm going slower. All right, so that's how you can think about it. If you're going faster, you're going to be adding the current. If you're going slower, you're going to be subtracting the current from your still water speed. Now, they said the total trip took 7 hours. However, the reason that I'm using T1 and T2 is this is just the time that each of these individual variables are just the time for one trip. So one way. So the round trip, if you added these together, would equal 7 hours. All right? But we don't know how long they took for each individual trip. Now, we're going to write an expression to describe T1 in terms of distance and rate. So first off, how do I find time in terms of distance and rate? What's the formula? T is equal to what? Distance over rate. So for T1, so that's the downstream, how can I write the formula using what I'm giving for distance and rate from the table? So what's my distance? 20. So 20 is in the numerator, all over what? 8 plus C. That's my rate. All right. Then we're going to do it for T2, for distance and rate. So we're still using the exact same formula. We're using T equals D over R. So T2 would still be 20, but it'll be over what? 8 minus C. So guys, we're literally just taking the stuff that we already had in the table and we're just writing it in the formula. Now, this is where the rational equation comes in. Since the total time is 7 hours, that means if we add T1 plus T2 equals 7, all right, we're going to use substitution and replace both of these expressions that we came up with in for T1 and T2. So our new equation would be 20 over 8 plus C plus 20 over 8 minus C is equal to 7. And there's our rational equation that we have to solve. Now, that's just with writing it. Solving it's going to be the same thing that we've been doing with the other ones. We'll use the LCD method, but we're not going to solve this one just yet. All right? We just wanted to make sure that you can set up the equation. So the hardest part of these, in my opinion, is the setup. If you can get the setup, the solving shouldn't be too bad. All right? In fact, I think some of the solving is actually easier than, some of the ones we've already done. Any questions on the setup and why it is the way it is? So again, it's just thinking logically, guys. So you know that the time for one trip plus the time for the other part of the trip is your round trip time, if you add them together. And so if we know how to find time using distance and rate for both, and we can write the expressions for them, we just add those two expressions together equal to our total amount of time. And then it's a fairly quick solve. All right. So now let's look at the steps for solving. So that's why I said we're not going to solve it just yet, because now we have the next part of the equation. So they rewrote the exact equation that we had up top here. So it's the exact same equation that we just came up with. Now we're going to figure out the steps for solving. So first things first, just like we've been doing, we need to find the least common denominator. So I'm going to put the 7 over 1 just so I can see all denominators. What do you think my LCD is for this? So think about it. What does at least one of the fractions have in the denominator?
There's a 1. What else does it have? At least one of them. 8 plus C and an 8 minus C. So since there's nothing in common, we're going based off of what they're all lacking. So when in doubt, just multiply all the denominators together. So my LCD would be 8 plus C times 8 minus C times 1. So 8 plus C times 8 minus C. Then we're going to use our expressions to clear the fractions. All right. So just like we've been doing, we're going to multiply this entire expression by 8 plus C times 8 minus C over 1. So remember, you keep whatever's in your denominator. So 8 plus C plus 8 minus C is equal to something over 1. And then we just distribute to all the other numerators, the 8 plus C times 8 minus C, but we don't actually do any foiling or distributing. We're just writing it out as a multiplication problem. So what do you think my first and second numerator would be if I distribute? If I just rewrite the multiplication, what would it be? So what's 20 times 8 plus C times 8 minus C? How would I write it? There you go. That's all you got to do, guys. You just got to rewrite it in terms of multiplication. Because remember, we don't want to distribute yet because then it would be really hard to cross things out. So this one would be the exact same thing. 20 times 8 plus C, 8 minus C. And then the 7 would be 7 times 8 plus C times 8 minus C. So a lot of things start to go bye-bye. What goes bye-bye in the first fraction? 8 plus C goes bye-bye. I'm left with 20 times 8 minus C. Plus, what goes bye-bye in the second? 8 minus C. This would be 20 times 8 minus C. Does anything go bye-bye in the last fraction? No, so we just bring everything down because it's divided by 1 anyway, so the fraction's technically already gone. So this is our new equation, and it's not a very hard solve. I think it's a quadratic, so it's not too bad. So we're going to do our distributing and foiling and simplify stuff down. So, yeah. Ah, Lord help. I told you guys, sign errors still get me too. All right. So we're going to do our distributing and foiling just to simplify what we got so far. So I got 160 minus 20C plus 160 plus 20C is equal to 7 times, this is just a difference of squares, so you just take the square of both numbers and just subtract the two. So 8 squared is 64 minus C times C is C squared. And then just distribute the 7. Now, quick question. Before I even distribute the 7, what's going on the left side if I combine like terms? What happens? What cancels? The 20C's cancel because one's negative, one's positive. So we really only got to add the two 160s. So that gives us 320 is equal to, can someone do 7 times 64 for me? 448 minus C squared, or 7C squared. You know what? Yeah, we're not going to do that. Shoot. How do I want to play this?
Nah, we'll do it. Okay, so this will be 448 minus 7c squared. There's a couple of different methods you can use to solve this. I was just kind of second guessing myself. All right. So I would say for this one, we don't necessarily want to solve by factoring. We can actually solve by a square root most likely. All right. So who remembers how to solve by taking a square root? Or we can try solving by factoring. You guys want to do that one? Okay. So I need to get one side equal to 0. Which side? So I would actually, in my opinion, move the c squared to the other side because you want that c squared to be positive. Because it just makes things easier in the long run. So I'm actually going to add 7c squared to both sides. So that gives me 7c squared plus 320 is equal to 448. And then subtract the 448 to both sides. So I have 7c squared minus, can someone do 320 minus 448? I know it's a negative number. 128 equals 0. Now, what's the first thing I got to do when I'm factoring? I got to check for what? A greatest common factor or GCF. Good. So what do you think my greatest common factor might be? I gave you a hint. What's the only two numbers that go into a 7? 1 and 7. So we're hoping that the GCF is 7. Is it? It's not? Gross. Okay, so then we are you sure it's not 7? I'm pretty sure it's 7.
Like you're saying it's 7?
128 divided by 7, what's that? Nope. Okay, nope. All right. So, since that's the case, we're now going to have to solve by taking a square root, which is what I wanted to avoid, but it's fine. All right. So, we're just going to go through and solve this. So, if you solve by taking a square root, we're actually going to add the 128 back to the other side because we want to get this c squared by itself. So, the 128s go away. We end up with 7c squared is equal to 128. Now, we're then going to divide both sides because we want the c squared by itself by 7. So c squared is equal to 128 over 7 and leave it like that. Because, yeah. Yep, you get a weird answer. All right, then we just need to take the square root of both sides to get rid of the c squared. So my suggestion to you is we're going to have a rounded answer. So I'm going to do second square root of 128 divided by 7. And we get about, let's say, 4.28 for our answer. So if we have that, that means our answer is plus or minus 4.28 miles per hour. Because remember, we're finding the current. Now, let me ask you guys this. Which answer makes the most sense, the positive version or the negative version? The positive version. Because, can we have a negative speed? Is it possible to have a negative speed? No. So our real answer is 4.28 miles per hour. That's what it means by checking to make sure your final answer is appropriate with the units. Yes. Yeah, right. So yes, you would have to do the squiggle. Yeah, it's technically not. Yeah. So this is the speed of the current. However, what did the original problem ask us? The original problem asked us to find what the speed of the current is. So yeah, we're right. I'm trying to do extra, y'all. So yeah, this is our answer right here. Yeah. All right. Any questions on that one? So sometimes you'll be nice where you can so a lot of times, especially when you're doing the distance problems, a lot of times it would be really easy to cancel out your x values and you just end up with something where you can just take a square root and round. All right. Now let's try another problem. All right. So I recommend that every time you do a distance problem, you just take a minute and create a quick chart just so you know what you're putting where. All right. So now we're talking about an airplane. All right. So a small jet has an airspeed, or the rate in still air, which good Lord, if there's a still air, is 350 miles per hour. So that's how fast it goes without wind. One day's flight, the pilot noted that the plane could fly 124 miles with a tailwind. At the same time, it took to fly 116 miles against the same wind. All right, and wants to know what the rate of the wind is. So, for those of you who either never been in a plane or don't really know how planes work, it's similar to boats. So let's say we had our plane. This is gonna look wrong, but let's say we have our plane. All right. So if I have a tailwind, where's the wind blowing? Is it blowing here or here? It's blowing with the plane. So it's blowing up its tail. So you think it's gonna go faster or slower? Faster. So this is the tailwind. But if it's a headwind, that means it's blowing against the plane. So it will go slower. It's like current. If you're going against the current or against the wind, you go slower. If you go with the wind or with the current, you go faster. So that's the headwind. So very similar to upstream, downstream, just different mode of transportation. Yep, because it just depends on the weather conditions that day. So now this problem's a little bit different than the other one because it doesn't give us a total time for the round trip. It just said it just took us the same time to go these different distances. All right. So what's our distance for the tailwind flight? So which distance, 124 or 116, did it said we go for a tailwind flight? 124. So that's our distance for the tailwind flight. What was the rate that we went? So obviously we're going to add it to the wind speed, so plus W, but what's our still rate? So if there was no wind whatsoever, well, how fast are we flying? 350 miles per hour. So 350. And we're going to call this flight time T1. Then what was the distance for the headwind? How far we go with the headwind? 116. Now, how fast did we fly in a still wind? 350, right? It's the same thing. And we're subtracting the wind from us because we're going slower. And we're going to call that time T2. Now, again, just a note, since it says the plane travels for the same amount of time both ways, that means instead of doing T1 plus T2 equals some time, we're just going to do T1 is equal to T2. So let's just write individual expressions first using T1 and TR and T2, Lord. So if I wrote T1 in terms of distance and time, or distance and rate, how would I write that expression? So T1 is the tailwind. How would I write that expression using the formula for time in terms of distance and rate? So remember, time is equal to distance over rate. Well, what's my distance for the tailwind? 124, so that's my numerator, over, what's my rate? 350 plus W. Then T2 would be what? As in terms of distance and rate? 116 over 350 minus W. Then we're going to take these two expressions, plug them in for T1 and T2. We're going to set them equal to each other. So I have 124 over 350 plus W is equal to 116 over 350 minus W. Now let me ask you this. Look at how your equation is set up. What would be the easiest solving method? So do you think I'd have to use LCD on this? No, because I only have one fraction on each side, the equal sign, right? So in reality, what method can I use? Cross multiplying. So since I only have one fraction on each side, I can cross multiply. So this would actually be a nice linear problem. We don't have to worry about quadratics. So if I cross multiply, I would get 124 times 350 minus W plus 116, or not plus, equals 116 times 350 plus W. Then I just distribute and solve. So I'm going to take a minute, distribute to both sides. Can someone do the two big numbers times themselves? So, because I don't have it written down from me. So 124 times 350, 455, 433. Lord. Thank you. 43,400 minus 124W is equal to 4,600 plus 116W. Thank you. Now, I would do some subtraction or addition on both sides. So I'm going to add the 124W to both sides so that I have a positive W. I would get 430,400 is equal to 4,600 plus, that'll be 0, 3, 230. Correct me if I'm wrong. 230W. Is that correct? It's 2 what? Dang it. So close. All right. Then I would subtract the 4,600 from both sides. Can someone do that for me in their calculator? To do 43,400 minus 4,600. 2,800. Cool. Equals 2,800. And then divide both sides by 240. So what's W equal to? $11.67. All right, so it's a rounding, so we're going to say it's approximately 11.67 miles per hour. So that's how much our wind was that day, which makes sense in terms of the problem. right. Last thing we're going to do today, we're just going to do one more thing and then we're done. I'm sorry notes took forever today. All right. Or are you guys kind of tapped out? Okay. I'll pick this up tomorrow because it's just a last little section for word problems. So we're going to stop for today. There is, you should be able to at least finish most of your Delta math now for 4.5, but there's also a quizzes for 4.4 if you want to start that, but you might want to hold off on that because of the other part of the word problems that we have to do. All right. But you can at least do some more of your Delta. All right. So again, I'm going to stop there for today. I will go ahead and put your exit ticket up if you want to go ahead and knock that one out.
I feel like I'm inside.